For our biofuel project, our chemistry group had algae, and the commercial cultivation of algae is called algae. And algae comes in two forms: macroalgae, which is like seaweed that can grow up to 180 feet in length, and microalgae, which is like tiny single-celled algae. And algae culture is attracting new interest today because part of the organic mass in algae actually takes the form of oil, and it can be squeezed down and used as biodiesel. And not only that, but algae can convert CO2 to usable products, and if it's put in like dirty water, it cleans it up very fast actually. So why pick algae? Well, the productivity of algae is extremely fast. It grows fast. It doesn't need a base to grow. Like a flower, for example, needs a base to grow, and it takes time and effort. An algae, it can literally just grow on the surface of the ocean. It doesn't need a base, and it grows extremely fast. The concentration can produce up to 100 times more oil per acre than most land plants today. One method for cultivation of algae is a closed-loop system in which you grow the algae in what is like a giant dome to try to prevent other organisms that might be floating around or other gases from getting to the algae. A problem with doing this is getting enough fresh supply of CO2 for the algae. That would also be cost-effective because it costs a lot. And experts think that one efficient way to do this is somehow keep a closed loop, but use CO2 from like heat waste, like excess CO2 in the atmosphere, to have the algae use that as a means to grow, because then it'd be cleaning up the atmosphere, and it would also be a less cost-effective means of the algae growing. Another method is which glass tubes are exposed to sunlight and nutrient-rich water is pumped through them, and these are called photobioreactors. These are actually very efficient and very quick at getting the algae like processed and getting the oil out, but it's also very costly. So, what the problem is that algae has various lipid counts, and the lower amount of lipids that it has, the longer strands that it will grow, and the faster it will grow. So the problem is finding a means to use photobioreactors, but find that perfect strand of low lipid algae that can grow really fast and be more counterproductive versus the cost of using these. The last method, and the least efficient to say the least, is open pond. Open pond is when you just let the algae grow basically out in the open. This isn't very efficient to grow the algae at all, because the most effective means would be to monitor the temperature and the pH and how much CO2 it's getting. But with this, you just kind of let it grow, so you never know how long it's going to grow, and a lot of scientists have rejected this, and not many people use it at all. But it's worth acknowledging because it is a way of growing algae. It's just not effective in business or getting a lot of oil demand for our population. There are some cons to algae biofuels, however. One risk is the open pod technique, in which you just let the algae grow out in the open and you don't monitor the pH or temperature. The problem with this is obviously that you won't get a desirable amount of algae, and you're just kind of letting it grow on its own. This isn't really a huge con, though, because scientists have turned down this option, and most people don't really use it anymore. Another con with algae biofuels is that they're not really tested. It was used in a Mercedes-Benz at the Sundance Film Festival in 2008, but no statistics were released on the car, like its mileage or what kind of emissions it produced after it was used. But I think that the pros outweigh the cons with algae biofuel, because if you can find the right low lipid count, you can grow a desirable strand of algae that can be used as potentially enough fuel for the whole population. The problem with growing algae is finding the right temperature and the right pH and the right amount of CO2 in a cost-effective manner. But the good thing about algae is that it can take in CO2 and produce oxygen for our environment. So not only is it using as a fuel, but it's also a great renewable resource because it is giving back to our environment as well. The problem is just finding a cost-efficient way to use it, like most resources that aren't petroleum.